Hi everybody, today we're going to start 2.2. It's the cast rule, special triangles, quadrantal angles, and equations. So part one, we broke this up in a couple of sections. Part one, we're going to look at the cast rule and special triangles. Okay? So the cast rule investigation, we're going to investigate what happens and where these things come from. This is just, instead of just me giving them to you, where does it come from? So suppose theta is any angle in standard position, and the point xy is any point on its terminal arm. At the distance r, so r is, they give that because it's actually radius, we'll look at a little bit of that later on, from the origin, then by the Pythagorean theorem, r squared is equal to x squared plus y squared, take the square root, and we get r is equal to the square root of x squared plus y squared. What we can do is we can use these x, y, and r and the reference angle to determine three primary trig ratios, which is pretty neat. So sine theta is equal to opposite over hypotenuse, so opposite of theta would be y, hypotenuse would be r. Cosine theta is equal to adjacent over hypotenuse, so theta is here, adjacent to x over r, and the tan of theta is the opposite over adjacent, which is y over x. So these ratios that we have opposite over hypotenuse, when we apply them to our quadrants, use a special triangle, we come up with these new equations: sine theta equals y over r, sine theta equals x over r, and tan theta is equal to y over x. So I know it's busy, but this chart summarizes all the signs of the trig ratios in each quadrant. I'm going to do a quick summarization for you in the next page, but this is where it all comes from. Okay, instead of me just throwing it at you. So if we're talking quadrant one, what I just showed above, sine theta is y over r, and that would be greater than 0, so basically it's positive. Cos is also positive, and tan is also positive. This is greater than 0. Alright? Why is r always positive? Well, r is always positive because your x value is always positive and your y value is always positive. Okay. So all your primary trig ratios, sine, cos, and tan, in quadrant 1 will be positive for that reason. In quadrant 2, we have 90 to 180 degrees, but you'll look, if you draw your reference angle, you'll notice that your x value is negative. Alright, that's because all your x values are negative in quadrant 2 and your y values are positive. So look at your point, negative xy. So that is y. R is going to always be positive. It's for radius. We'll talk about that another time. But if you look, your x is negative. So sine is still positive because sine, as you recall, is opposite over hypotenuse. The y and the r are still what? Positive. So we end up with sine theta positive. Cos theta, however, is adjacent, and your adjacent side is negative x over r. R is obviously positive, so a negative divided by a positive will end up with a negative. So therefore, the cos of whatever angle you take between 90 and 180 gives you a negative number, and that's why. Interesting. Tan theta is equal to y over negative x, and again that would be negative because a positive divided by a negative would be negative. Alright? Let's go down to quadrant 3, where your x and y are both negative. Alright? So what happens here with sine? Well, if sine is negative y over r, that would be negative. If cos is negative x over r, that would also be negative. But tangent this time is a negative divided by a negative, which is a positive. So that means if you have any angle of tan that you take between 180 and 270, so if we take like the tan of 200, it's going to be positive. And you can check these on your calculator if you wish, and it will hold true. And then in quadrant 4, when you have angles between 270 and 360 as your reference angle, as your principal angle, it'll always make your reference angle your triangle. I do apologize for that. So your sine is negative y over positive r. So sine is negative. This time cos is positive because x is positive and r is positive, and tan is negative, so it's negative y over x. All right. So what does that mean? Well, in summary, I did a summary chart for you. Basically, this chart is the same as the one above. So we got quadrant 1. All primary trig ratios are positive, hence the A. That's why it's cast rule, C-A-S-T. So A, or some people use it as all students take chemistry or calculus. So that's what they call it, the cash rule. It's just something to remember. So quadrant 1, they're all positive. S, quadrant 2, only sine is positive. Quadrant 3, T, only tan is positive. And quadrant 4, cos the C is positive. So that's a summary. Once you get the hang of this, you start playing with them. Again, the way to check it is you literally click anything on your calculator. If I take the cos of any number between 270 and 360, it'll give me a positive value back. Okay? Let's look at the example. So example, we have a point P, negative 3, 0 lies on the terminal arm, so that's right up here, negative 3 and 4 of angle A in standard position. Determine the exact ratio values for sine, cos, and tan. So what I had to do is first I had to calculate the R value, which is the hypotenuse. We have the reference angle here and creates a triangle. So that would be R squared is equal to X squared plus Y squared. R squared is equal to X squared plus Y squared. So negative 3 squared plus 4 squared gives you 25. Square root of 25 is 5. We don't worry about the negative value. It's a length for a radius, so it won't be negative. And our trig ratios, remember, sine is Y over R, so it's 4/5. Theta is equal to negative 3 over 5. And the tangent is equal to 4 over negative 3. And we usually put the negative up front or in the numerator. We usually don't have a negative in the denominator. That's just a rule of thumb, say. Okay? Let's look at the next example. We have here, it says point, negative 7, negative 5. So you know that's in quadrant 3. So you can predict right now that tan is going to be the only one that's positive. Alright, so we got to find the R value. It's the square root of 74. I left it as the square root of 74. And the reason I left it as the square root of 74 is 74 does not have any perfect square factors. So if you look at 4 doesn't divide into that to give you a decimal. Try 9, 9 doesn't work, right? Because 9 times 8 is 72. And 9 times 9 is obviously 81. And then you can try the next one, 16. No, 16 times 4 is 64. 16 times 5 is 80. And you'll notice very quickly that, yeah, in 25, no, it'd be close, it's 75, but it doesn't work. So 74 is the simplified entire radical. It can't be changed to a mixed radical. So that's why I left it as 74. I know I left these in the denominator. I will leave them in for now. You can rationalize them if you want. It's up to yourself. So y is negative 5 over r root 74. X is negative 7 over r is root 74. And y over x is negative 5 over negative 7, which is 5/7. So quadrant 3, sine is always negative, cos is always negative, and tan will be positive, as you can see. Let's look at the next example. It says angle A terminates in the second quadrant with the cos of A equal to negative negative square root 2 over 5. Determine the exact value of tan theta. So we know we're in quadrant 2. So that means that our x value is negative 2, and our r value will always be positive as 5. Right? So if it's negative, that'll go with the numerator. Okay? So we calculate the y value when we get the square root of 23. Put 5 in for r and the square root of 2, negative square root of 2 in for x. So we square 5, we get 25. Square root the negative 2 squared, negative times negative is positive, and the square root of 2 times square root of 2 is 2. So that's where the 2 comes from. Subtract 2 from both sides, we get 23. Take the square root, and we get a y value of the square root of 23. And I've rationalized the denominator for tan to show you that, because it asks for the exact value of tan A. So tan A is the y over x, which would be the square root of 23 over the square root of negative square root 2. The negatives out front, and here's I've rationalized the denominator, so I take the square root of 2, multiply the numerator and denominator by the square root of 2. Square root of 23 times the square root of 2 is the square root of 46, and the square root of 2 times the square root of 2 is 2. And we get the tangent of A is equal to negative, and we know it's negative because it's in quadrant 2. The only positive trig ratio is sine in quadrant 2, as you can see from the summary above here, right? Quadrant 2, tan is negative. Alright? Let's do the last example, then we'll start the special triangles in the next video. So if we have the tan of theta is equal to 3 over 2 root 5, so we know that 3 is y and 2 root 5 is x, because tan theta is equal to y over x, so that's where those come from. They're both positive. Alright, and we're looking for sine. So these we think are positive at first look, but remember it tells us the cos is negative, so the only time we have a tan being positive and a cos being negative is quadrant 3. If they were both positive, then we'd be talking quadrant 1. So that's why these become negative. They look like they're positive, but they're actually negative because they're both quadrant 3. So that's where you got to look at. That's what this tells you. This tells you it's positive, so it's quadrant 3 or quadrant 1. And the cos being negative tells you that it has to be, therefore, quadrant 3, because quadrant 1, as you know, has everything positive. Alright, so that's where the negatives came into play. Not that it'll make a difference finding your R value, but it does make a difference when you're looking for the sign, right? Remember, quadrant 3, sine's negative, so the y value is negative. Okay, so that's it for the first part. I'll start special triangles in the next video when we return. Thank you.